Okay, so the next part of our geometry chapter is covering volume and surface area. We are going to talk first about the volume of prisms, and there's two different kinds. There's a rectangular prism and triangular prisms. For a rectangular prism, let's talk about those first. I think of a cereal box when you're dealing with rectangular prisms. And if you were to draw one like Miss Chiano, you do a rectangle, and then you kind of draw another rectangle, and then you connect the edges. Okay, so I always think of, again, a prism. Remember, the definition of a prism is that it has two bases, the top and the bottom. There's your two bases, top and bottom. It has two bases, so remember that. Rectangular prism, because I see a rectangle, it is not a perfect cube. Okay, a cube has a perfect amount of dimensions on all sides. And this is what makes up a rectangular prism. It has a top and bottom, two bases, and it's rectangular because it's in the shape of a rectangle. Volume. Let's talk about what volume means now. There is a formula for solving for the volume of a rectangular prism, which is length times width times height. This was introduced to you in a previous year, okay? Length times width times height. And what volume is that you are actually measuring how many cubes fit inside a rectangular prism or a triangular prism. You're actually measuring cubes. So you know how when we were solving for the area of a rectangle, and that is length times width, because you're actually using squares, like how many squares make up that shape? Well, with this, you're actually using cubes. So like how many cubes fit inside this rectangular prism? So you're going to be cubing your answer today. So for example, let's say that the height of this rectangular prism is 8 centimeters. And if this side's 8, this side's also 8. So you got to be careful of your dimensions. The height is 8. So if the height is 8, let's say the width is 2 centimeters. Right here is the width, how wide it is. And the length right here, let's say 5 centimeters. So let's plug in what we have here. Remember, order doesn't really matter when you're multiplying straight across, okay? You could do 8 times 2 times 5, 5 times 2 times 8, but I do want you to start identifying what the height is, what the width is, and what the length is of these 3D solids, because it's going to matter in a couple lessons. So again, the length looks like it's 5, the width is 2, the height is 8. Go ahead and solve it. That's 10 times 8. Volume is 80, but 80 what? Centimeters cubed. Remember, you are cubing your answers because you're actually measuring with cubed. The 3 stands for cubed. When you were solving for the area, length times width, that was 2 times 3, and you got 6 centimeters squared when you're solving for area. But when you're solving for volume, you are cubing your answers because you're actually using cubes. How many cubes fill in that 3D solid? And that's for a rectangular prism. I want to go ahead and do one more rectangular prism. Sometimes they're going to be sideways, such as this. Okay. In this case, I'm going to say your height is 3 inches. The width here, I'm going to say is 4 inches, and the width is going to be, let's just say 7 inches. Using the formula for a rectangular prism, length times width times height. So you're going to go ahead and do the length, which is 7, times the width, which is 4, times the height, which is 3. 7 times 4 we know is 28 times 3. 28 times 3 is 84 inches. Inches what? Whoops, sorry. Inches cubed. You are cubing your answer because, again, you want to know how many cubes fit on the inside of that prism. That's a rectangular prism. And again, length times width times height was taught to you last year. What's new with the 7th grade skill is triangular prisms. So let's go ahead and do number 2 with a triangular prism. I always think of a tent. So like if you're pitching a tent and going camping, and we practiced drawing these in a previous lesson. Okay, just follow Miss Chiano. Okay, draw 2 triangles, similar in size, and then connect the edges. This is the back. That's why I'm putting it dotted. And now we have our tent. We do have a height of our tent. The height right here is, again, what you see dotted. This is the height of that tent or triangular prism. I'm going to go ahead and name that real quick. It's a triangular prism. And this guy was rectangular, just like up there. The height, I'm going to go ahead and label it is, I'm going to give you decimals this time, 4 1/10 meters. That's a 4. 4 1/10 meters. I'm going to say the base of that tent or triangle is 2 6/10 meters. And the height necessarily is 5 1/10 meters. So I know it doesn't look like it's the height. You might want to call it the length. But if you were to take this prism and you were to prop it up, this would be the height, wouldn't it? If it were a tent. It's a triangular prism because our bases, their 2 bases, are the shape of a triangle. Okay. Now, you got to apply the area of the bases multiplied by the height. And that's what we did up here. The area of the bases, so length times width is the area of a rectangle or square. Same with a triangular prism. I told you that the area of solving for the area of a triangle is 1/2 times base times height times the height of the whole prism. So let's go ahead and solve for what's the area of just the triangle. So 1/2 times the base, which is 2.6 or 2 6/10, times the height of that triangle, which is 4 1/10, times the height of the whole prism, 5 1/10. So that's what we plug into our formula using substitution. Let's go ahead and solve. Once you plug this in your calculator, order doesn't matter. 0.5, which is half, times 2.6 times 4.1, you'll get 5 33/100. Now let's multiply that to 5.1. Sometimes we should probably use our little x to indicate that we don't get it mixed up with our decimal. Go ahead and multiply those together. Rounding to the nearest tenth, you'll get 27 2/10 meters cubed because you are cubing your answers. Okay? All right. Remember, we half it because we know that squares is what we're using to measure area. And remember this, we half it because isn't a square 2 halves of a triangle? Okay? When you cut a square in half, you get 2 triangles. That's why you half it in your formula. Let's do another one, number 3. Another triangular prism, but this one's going to be a right triangular prism. So I'm going to go ahead and draw it like so, and so are you. Connect the edges, and it's a right one. So with this triangular prism, I'm going to go ahead and label what we have. We have a height here, so that's what's different between this triangular prism and this triangular prism. Remember, the true height goes from the vertex down to the base. When here with the right triangular prism, you actually have a height where you don't take it in the half. So we have 6 meters. I'm going to go ahead and say that the length here is 12 meters, and the base of this triangle is 8 meters. So plugging it into the formula that we know, 1/2 times base times height, times the height of the whole prism. Let's go ahead and solve for the area of just the base. So that's 1/2 times the base, which is 8, times the height, which is 6, times the height of the whole prism, 12. Solve what we need in parentheses first. 1/2 times 8 times 6 is 24. You can do some mental math. I know 8 times 6 is 48. What's half of 48? 24. Now 24 times 12, your volume is 288 meters cubed. Because again, you are measuring how many cubes fit inside that triangular prism. So there's two examples. I just want you to make sure that you are careful and making sure that you understand that the volume means actually how many cubes fit inside that triangular prism or that rectangular prism. So just a quick visual. Here's a perfect cube. I want to know how many cubes fit inside this rectangular prism, for example. Okay? That's an example.